In this video, we will continue on the series of Don't Eat the Yellow Snow programmed in Lua and the Love2D game library. If you're just starting out with this video, you'll want to go to github.com, programming rainbow. Right here, github.com, programming rainbow. You want to go to Yellow Snow Lua Love2D. That's the repository. You'll want to clone this repository, move inside of it, and since this is the third video, we are continuing off with code that we finished in the second video. So you can remove anything that's Lua, delete anything that's Lua if you're just starting out with this video, and then copy over the files from video 2, these 4, into here. And you'll be right where we are right now in this video. Okay? And before we go into this video, I just want to fix the name. So I've used snake case name here and then camel case name here. So I'm going to switch this one over to camel case to make it more in line. And so down here, I also need to fix it where I'm actually using it. Just want to make sure everything is kind of on the same page. Okay, so this video, we will be making flakes. So we'll be making the snow and we will make it appear randomly above the screen and fall down. Okay, so we're going to do the exact same thing that we did with the player class, and we're going to use that same setup to make a flake class. So I'm going to make a new file. I'm going to close this video too. We don't need to look at that. So in here, I'm going to make a new file. I'm going to call it flake.lua. And basically, since we're doing the exact same thing as player, I can just go in here and I'm just going to copy this. We're not going to use exactly everything in here, but this is a good, since we've already done this once before, I'm just going to go ahead and copy it. See, there we go. Put it in here. Obviously, this is going to be called Flake. So I'm going to create a local table up here. Call it Flake. This is going to be our class name. So this player needs to be Flake and new Flake. So we will be pulling the image in and we will be getting the dimension of the flakes, but we will add another Boolean. So let's just convert all this over. I'm sure there's a very fast way to do this in NeoVim. I'm actually not an expert NeoVim programmer, so I'm just going to change each one the hard way. We're going to use the exact same method for the image to get the dimensions of the image with the flake width and the flake height. So we're using that exact same. So we still have the image coming in, and we will be doing running the method image getDimensions, and that's going to return the width and the height. So it's returning two values. We're capturing them inside of this table, which is going to be .width, ._width, and ._height. And again, I'm using these underscores to show that these are meant to be private properties, but Lua doesn't actually have private properties, so this is just a convention. Again, anywhere in my code, if I'm ever accessing anything that's at an underscore, I know that it should say self in front of it. If it says self and then it's got an underscore, I'm fine. I'm accessing it, my own internal variable. If I'm accessing anything from outside, then we want to be using something like a getter, where I'm going to do a return on the value of the private so it doesn't get changed from some external source. Again, this is just convention, and I'm using that convention. We don't need to really worry about this line right here. I'm going to get rid of it. It's just going to complain until we've set this up a little bit. So flake, and this one is going to be flake. So that's kind of the basic thing that we're setting up here. I do wish to add one more. I want a property. I want a variable inside of the flake that is going to tell me if this is a white flake or not. You know, it's either going to be a white flake or a yellow flake, but I'm just going to use a Boolean and say is white. I'm going to be passing in another one that is just going to be is white. And so I don't have to deal with the string. You know, I could pass in a color and put a string as white or yellow, but if I just say is white, it's a Boolean. what I'm going to do is I'm going to save that. Under the image, I'm going to use new flake. And then I'm going to do this is white with the underscore. And it's going to equal is white. Okay, so I'm passing in that boolean, so I know if this flake is a yellow flake or a white flake because it matters on the collision if we're colliding with a white flake or a yellow flake later. So that is going to be everything that we need in this. We will tell this to draw itself, and yeah, let's just initially have it draw itself so we can just see the thing working. So I'm going to make a new function down here. And we're just going to draw this the exact same way. The very simple, the love.graphics.draw, and we just need the X and the Y. We're not doing anything else that's fancy. We're not flipping it or anything. So in here, we've already seen this several times in the prior videos. This is love.graphics.draw. And we have the image that we want to draw, which is going to be self underscore image. And then next, we actually want the X and the Y because we want to know where this is being drawn on the screen. So I'm not actually setting the X and the Y yet, so I'm just going to leave this off for now just so we can draw it and see that it's working. We're going to go back to the game and we're going to bring it in the same way that we did before. So here I'm going to do local flake equals require. This just pulls in the module, gives us access to that Flake class that we just created. So again, this flake right here is talking about the actual file name right here. Flake.lua minus the .lua, just the flake part, needs to match right here. This is what I've decided to use, and again, because I'm looking at like this as if it was a class, I'm going to use Pascal case, so it's going to be capitalized, and that's how I'm doing it with all of my code. We do want to load an image for the flake. So we have two images. We have it over here on the where the images are, and we have a white and a yellow flake. So these are just snowflake images. So I'm just going to load both of them. And we'll say white image and yellow image. And we've already looked at this function in the last video, or the last two videos, so I'm not going to pull up the page again. This is just kind of redoing what we've already done. And I'll just copy this right here, since it's the same. I will change it to yellow. Okay, so we have the white and yellow images loaded. But remember, we're passing two things in when we create our flake object. So let's just make one flake for right now and show it off and see what it looks like. So I'll say local flake, and this is the instance of it, so it's just lowercase, equals flake new, and we need to pass in what we want. So let's do the yellow flake instead of the white flake. So we'll do the self.yellow image, and we need to pass in the is white boolean. So the yellow flake isn't white, so we'll put false. Okay, so that's just the boolean. Anytime I'm making a white flake, I'll pass true in. When I'm doing a yellow, that's just so the flake itself knows that it's white or yellow. I don't need this local here. It's self. So because this flake is inside of the game. Okay, so we're creating just one flake, and we didn't set it an X and a Y, so they're both going to be set to 0. So this flake is going to show up in the very top left-hand corner of the screen, and we're not changing the size of it or anything else. We do need the flake to draw itself, so we're going to go down to here, self.flake draw, so that flake will draw itself. And I think that's all that we need right now, just to draw this one flake on the screen. Let me just make sure all the other files are saved. What did we have here? Oh, that's player. Oh, the other thing is you might see that there's different symbols here and there's X's and all this stuff. This is because I cloned a Git repository and then I'm changing things. We don't actually need this. We can get rid of this .git directory right here, and it won't be telling us we're changing stuff because we're not pushing this back up. We can just delete this or remove this file, and I'll probably get an error message when I do this because part of NVChad there is a Git module setup that's running all this stuff, so it might complain, and I'll just restart it. See, there we go. Or I'll just ignore it. I'm going to run it, and we should have in the very top left-hand corner, we should have a yellow flake. Okay, and I've done something wrong here. Attempt to index up value flake, a Boolean value. Well, it's at game 15, so let's check out what's going on there. It's leader in, where was it complaining at? Let's check it out again. It's complaining at game 15. So let's go to game there, and game 15 right here. So I'm just going to make sure I'm spelling everything right. So I'm bringing in flake, and that is spelled the way that is spelled. Requiring it, I'm calling it flake with capital. Self.flake, and then flake new. Yeah, that all looks good. It's right here. It's not liking this at all. Let's check if the flake new is spelled correctly in the flake. Okay, here's flake new. Oh, I need to return this. Yeah, I forgot to return the table at the bottom, so that's probably what it was. And we have in the very top left-hand corner, we have our flake being drawn. Now, if I do a white one as well, it's going to be in the exact same spot, so we need to make it a little more complicated. We want to make more flakes, but also we want them somewhere above the screen, so they come down onto the screen and look like they're falling like snowflakes. So I'm going to make a method called flake reset, and it's going to basically put my flake in a random position above the screen. I actually don't need all these open. I'm going to close them all. The only ones I need open is flake and game. There we go. I'm going to create a new one, and this is just going to be like making sure that the flake gets put in the random place that I want it to be put in. Now I'll call this one reset. And we don't need to pass anything in just yet, but later on we will. So what I want to do here is I want to put a random number for the width, for the X. I want it to be randomly somewhere on the screen. And also for the height. So let's start with the X. The X is because the height one, we're going to have two versions, so let's start with the X. So I'm going to go self.x equals, and I'm going to use math.random. Let me show you this real quick. So this is just built into Lua. Math.random, that method, it can give us random numbers. And when we use a range, it's inclusive. So it's going to be both sides. So if I use any kind of range like down here, math.random 4, 8, it's going to give me numbers from 4 to 8, but it's going to include 4 and 8. That is up to and including, yeah. So this is inclusive, so it's including the number on both sides of what you're doing. Okay, it's just a very simple thing, and that's what I want to use. So I'm going to say math.random. And this is, like I said, just built into Lua. It's just a normal Lua thing. And I'm going to have the range going from 0, because this is my X. So if it's at 0, it's going to be all the way at the left of my game screen. But I don't want it all the way at the full size of my game window, because that wouldn't make sense. It would be drawing off the screen, because that would be the left side of my image. So I need the whole width of the screen minus the width of the image, so I could draw the left side of the flake where I'm seeing the whole flake on the screen. So I'm going to use the screen width, the get width of the game, and I'm going to subtract the width of the flake. So this is this is my starting part of the range of my random number, and this will be the finishing part, the second part. So my number is always going to be in this range. So I'm going to use love.graphics.getWidth, just like we did before in the player, to be able to get the width of the game screen. So getWidth gets the width of the screen. Whatever you've set your resolution to, it'll be that. And then I'm going to subtract the width of this actual flake, which is self._width that we're setting up here. Okay, so this is going to give me a random number so that the flake is randomly somewhere on the x-axis, but it is always on the screen. It's never halfway off the screen or all the way off the screen. It's always on the screen. So let's just try that real quick. Okay, the reason why it didn't work, I closed it really quickly, but it was showing in the top left-hand screen, is because I did set the X, but I'm never using the X down here. So let's just add that so we are using it. And we still have the same issue. Oh, we're also never calling reset on this as well. So I'm going to call reset on this from actually inside a game, and this will make a little bit sense. This will make more sense in a little bit. But right here below where I'm making the flake, because I'm just making one flake right now, but we're actually going to make a whole bunch of these. I'm going to tell this flake to reset itself. Okay, so we see the flake is here now. I'm going to close it and I'm going to keep closing it and reopening it several times so we can see. It does look like it's always showing up right here. Yep. So we probably need to seed it. Generate a random number. I'm going to use this right down here, this math.randomseed, and we'll just use the os.time. Basically, the random number generator is generating a random number for us every time, but it's a mathematical equation. But the problem is it's starting out in the same spot every single time. So it's kind of like, imagine if your random number generator was like pi. Pi's got this numbers that extend on forever, infinitely. But if I always start at the first number, I'm always starting at 3. If I just keep always starting at 3, it's not really, it's more interesting if I start at a different spot each time. So they're using the time, the actual OS, the operating system time, to seed the random number generator. So this is going to be good enough for us. We're just doing a simple game. Let's put it up here. I don't need to say what it's doing. It's pretty obvious what it's doing. So let's see if, again, we get that same spot. There it is. I'm not loving how the distribution of numbers are, but it looks like we are getting a different number each time, but it does look like it's always kind of up there. That could have just been a luck that it was up there a lot of times, but it is not the same each time now, so looks like that's fixed. Okay, so we have this single flake, and we want to actually make lots of flakes. We also have this problem that we're only changing the X, not the Y. So let's go back and let's set something for the Y as well. So on the Y, I have two. I'm going to show Y in a minute. I have two versions of this, but I'm going to say the exact same thing for this, but I'm going to use getHeight, and I'm going to set it to the Y. But we'll actually have two versions of this. So we're doing the Y on this one, and it'll be getHeight. So we got getHeight, and then we actually need to change this. And I don't want it inside the random number generator. I'm going to do it outside of the random number generator because I want the image to not be on the screen. Before I wanted the image to always be on the screen. This time I don't want it to be on the screen. So my starting point for this image needs to be above the screen. So I need to start at negative self._height. That's my starting point. That means the image will just be above the screen. And that'll give me my image will always be above the screen, somewhere in, if you imagine one more screen above the visual screen that you see, it's going to appear somewhere in there. Okay, this is not perfect. There's a problem with this that we'll cover, but I just want to have it just be good enough. This is not right here either. This needs to be minus. So we're starting with negative self height. That's our starting point, and we're going to subtract from that the random number. It could be 0, or it could be a whole number height above us, but it's always going to be the negative because we're on the Y, so that's going to be above our screen. Let's make these flakes move. So I want the flakes to move at a speed, the same speed as the player was moving, which was 300, so I'm going to add that up here as a constant. So local, we'll call it flake, and it's all going to be capitalized because this is the constant. And this is 300 as in 300 pixels per second. Again, this was covered in the last video. Above draw and below reset, I'm going to make a new function for update. And I'm going to pull DT in right away. Again, we covered delta time in the last video, but it's just how much time has passed since the last game tick. So it's going to be, should be around 1/60th of a second, but you could have slower hardware or whatever, and that is able to kind of adjust for it, make sure the game is always moving at a correct speed, no matter if your computer is fast or slow. So these flakes are only going to be falling downward, so I'm only going to be changing the Y. I'm never going to be changing the X. So we're going to go self._y, and it's going to equal self._y, and then we'll say we're adding it. So by adding a number, it's going to go down the screen. Remember, we started with the negative numbers, that they will show up above the screen. And as we make the number bigger in a positive direction, it's going to fall downward. So we start up with a negative number, that means it's not viewable on the screen. And we're going to just keep adding a positive number till it becomes positive. It shows up on the screen, and then it moves down the screen. As we update it, we're going to use flake speed times delta time. So we're going to add that to whatever the flake currently is. And I can do the adding and multiplying here because the order of operations says multiplication happens first and then adding happens second. But if you aren't comfortable with that, you could just add parentheses around as well. It'll do the same thing. Okay, so this is going to update the Y. So if we test this, we should see a flake that we can't see, but then it should show up on the screen after a random amount of time because it's one screen or so above us, and then it should fall down. So we need to go back to game, and we need to call this update. And we do need to pass in the delta time. So we have our one flake. It should be randomly somewhere above the screen and then fall. And it's not. We are not using our Y position yet. Okay, here we go. And it falls off the screen and it keeps going. Let's make sure that when it does hit what looks like the ground, basically when the flake is halfway penetrated into the ground level, I want it to reset to another spot randomly above the screen. So we're going to use our reset function to reset it. So this will be in the update. We're going to update the flake, and then we're going to check to see if the flake has hit the ground yet. The ground, I had to guess again. This is just trial and error till it looked like where the flake was about crashing into the ground. It was about 550 pixels. So I'm just going to put that as a constant up here. That was just trial and error. You can play around with it as well. I'm going to put this ground height 550. So down here in update, I'm going to say if it's bigger than ground height, we're going to reset it. So it looks like I'm checking the bottom of this flake. The ground height, I'm checking the bottom, not the top of the flake. So I could just adjust this to be the height of the flake, but I actually need this bottom later on. I need to know where the bottom of this flake is when I'm checking collision with the player, and that is going to be a getter function. So I'm just going to create that since I'm using it down here. I don't have to use it. I could use the top, and I could just calculate against the top, but since my code is already using the bottom, that'll give me an excuse to make this getter function. So under reset, I'm just going to calculate what the bottom of the flake is, which would be flake y plus flake height. And this, I will call this bottom. And this will be accessed outside of this class. That's why I'm kind of using this getter function. So I'm just going to return flake y plus flake height. And that gives us the bottom of the flake. So now down here, if I go self bottom, and I want it to be bigger than this constant we made for the ground height. So if it is, we need to reset the flake. So since we've already got a flake reset up here, I can just say self reset, and that will be that. So now when the flakes come down and hit the ground, they will be reset above the screen. So it's about to hit the ground, and it disappeared, and now it's coming down again. You see, it's kind of when the center of the flake is kind of there. It was just trial and error. I just made the game go really slowly until it was at a spot that I liked, and it just happened to be 550. And that's 550 of the bottom of the flake, not the top of the flake. So that will work on all the flakes, whether they're white or yellow, we can reset them on the bottom. So what we need is we need a whole bunch of flakes. I'm going to make a table of flakes, and then I'm going to start filling it up with a bunch of flakes. So I'm just going to go right here. I'll put this as a I'm going to make a self.flakes. So it's not one flake, it's flakes, and it's just a table. And then I'm going to use a little for loop so I can count to a number. So I want to do something 10 times. I want to make a flake 10 times, basically. So I'm just going to use a for loop to do that. And I don't care about the actual number that I'm doing in the for loop. I just want it to happen 10 times. So I'm going to use an underscore because I don't need to name the variable that's going to be the 1 to 10. I don't need to name it because I'm not going to use it. So I'm going to say underscore equals 1, 10, 10 do. So this will do something 10 times, and we're not even capturing the number that's being generated here. And I'm going to put this in here. Okay, but what I want to do is I want to make 10 white flakes. I'm going to change this to white, and I'm going to change this to true. And then I'm going to call reset. Well, I could have left it as yellow. So let's I'm going to yank this and then I'm going to set it back to, to yellow. And I'll just paste the other one above. So now we have two lists. And we need to put the flake that we're generating inside of the flakes list. So I'm going to call the reset first on it. That's just to make the x and the y a random number using the reset method. And then after that, I'm going to place this single flake into the table of flakes with a table insert. And this one will be self flakes. And this should be a local. Sorry, I'm messing up here. This is going to be a local, and yeah. So we're making a local flake, and then we're putting it inside of our table, which is going to be flake. Okay, so let's walk through this again because I kind of messed this up in different places. Basically, I'm making a for loop that's doing 1 to 10. I don't care about the actual iterator at all, so I'm just putting an underscore. And I'm making a local flake, so it's going to be local to this for loop. And I'm creating as a white flake. I'm setting it to true because it's a white flake. I'm running the reset method on it to give it a random x and y, just like we were doing before. And then I'm taking this flake that's local to this loop, and I'm putting it inside of this table right here, this flakes table. So the flake is going in the flakes table. Okay, and I'm doing the loop again. I need to fix this loop, obviously, for yellow flakes. And I'm going to put yet less of the yellow flakes, but you can change this to however you like it. And we need to add it to the flakes table. Okay, so we should have 15 flakes now, but we can't update them the way that we were updating them, and we can't draw them the way that we were drawing them. We have to run through a loop to do this. So I'm going to do a for loop going through the flakes with I pairs. So I'm going to do it both on the update and the draw. So I can say, I'm again, don't need the iterator, so I'm going to use the underscore. For underscore, that just means I'm not using it. Because it'll give us the flake, which is the item in the table, but it'll also give us the number of it. And I don't care about the number of it, I'm not using it, I just want the flake. In I pairs. And the table that we're getting this from is self.flakes. Okay? And what do we want to do with the flake? We want it to update itself. I'm pretty sure I spelled I pairs wrong. Yeah, I did. And we need a do at the end of this. So this exact same setup I'm going to use down here in the draw. So I'm just going to copy this. And down here where I'm drawing the flake, I just need to change this update to draw and take away the delta time. Okay, so basically this is going through however big this table is, however big this table here ends up being, it's going to run through the entire table. It's going to take each item out of that table one at a time, and it's going to call it flake, and it's going to call its own update method on that flake. It's going to run through the whole table of flakes to do that, and then the same thing. It's going to run through the whole table of flakes, pulling each one out one at a time, calling it flake, and then telling it to draw itself. Okay, so now we should have white and yellow flakes falling on the screen. Okay. Now there is a slight problem with this. So I'm going to move this down. Let's see, I'll move it down here. So imagine that every time a flake resets, I'm going to move down a little bit further. Imagine that this is the screen above, up here above it, right? So every time one of these flakes hits the ground, it's going to reappear somewhere in a screen above. It could be here, it could be over here, here, it could be up here, here. So that's fine when it's playing. That means every flake that is in the table that contains the 15 flakes, is always going to be somewhere on the screen to the ground, all the way up to above here. All the flakes exist here in the screen size and one screen above. That's where every flake exists. But when the game first starts, all of the flakes all 15 start out up here, so they're all bunched up together. They start out in a smaller space, and they all come down as a sheet, and then when they start hitting the ground, they start randomizing. And I don't like this. So if it's kind of 2 screens worth of space that the flakes could exist in, when I very first start the game, I want the flakes to not exist in one screen above. I want it to be 2 screens above. Between here, right above the screen, all the way up one screen and a second screen. I want it to be randomly somewhere 2 screens above, so that it will be distributed when it falls down. But I don't need that to happen on the resets. On the resets, when it hits the ground and it resets, I only need it one screen because the game's already running now. So basically, I want the flakes to be correctly distributed. When I very first start the game, I want them to be distributed within a 2-screen size, but above the screen. And as they're hitting the ground, now we know the game is playing and the flakes are already on the screen and some of them are still above the screen. So now they can distribute evenly just above the screen. So I need 2 different setups. So I'm going to close this. So I'm going to go into flakes, and where I'm doing the reset here on the Y, I actually want to know if I'm going to say it's a full reset. If I'm fully resetting the game, I want the flakes to randomly be from right above the screen to up to 2 screens above. But if it's a normal reset, I don't want that. So I'm going to pass in something to reset. I'm just going to call it full, and it's just going to be a Boolean. I'm going to say full, and this will just be a Boolean. And I'm going to say if full, then. And I'll put an end here, and I'm just going to copy this one and put an else on it. So right here between them, I'll put an else. Okay, so now we have the exact same code twice. But if it's the full reset, like I said, I want it to start from the same place, but I want the high number to be not 1 screen above, but 2 screens above. So I want to multiply this by 2. So right here, where I get the screen height, I'm going to put a multiplier of 2. So it's going to go from 0 to whatever the screen height is, which is 600. So it's going to be 0 to 1200. But that's all on the negative because it's above the screen. On a normal reset, it's going to be 0 to 600 above the screen. Okay, so on the normal reset now, when it hits the ground, I do not need it to do the full reset, so I'm going to put false here. But on the game, when it's doing the when it's initially creating these, I do want it to do it, so I'm going to put true here. And now let's make it tell us if we've done this right. I'm going to put a print on just the full reset, not on the other one. Or I could, yeah, I'm just going to put full. I'll add another one here. Print not full. So now in the very beginning of the game, it should print full 15 times. But when the flakes start hitting the ground, it should print not full for each one of those flakes. Let's see if that works. Okay, there's our fulls. Now their first flake, there we go. And they're all not full now. So basically, hopefully it's distributing our flakes a little more evenly so we don't get a wall of dense flakes in the first couple seconds of the game, and then it thins out. I want it to be kind of even. Okay, so I'm going to remove this printing. So that takes care of the reset. So now there is a Boolean on the reset, and there's a full or a not full version. The X is always the same. We have our bottom getter. We are updating, and we do want to pass in, if it'll automatically be default, but we want to just do good code, so we'll pass that in. So now here we can change this number. If we wanted more yellow, we could make this number bigger, or, let's say if we put this to 15 and then put this to 10, we will get more white flakes and more yellow flakes too. 5 more of each. Okay, yeah, there's more flakes on the screen. There should be the numbers we chose. Looks like 25 flakes, but some of them will be above the screen. And they're all resetting when they hit the ground level. Okay, so I'm going to put this back to the default. You can play with whatever numbers that you like to use. I'm going to put this at 10 and 5 just for the tutorial. And these flakes are all using delta time just like we've done before. That's it for this one. That we created a Flake class. We used the same idea as before to do our constructor. So it's just returning it. It's setting the meta table to the actual flake. So it's going to get access to all these methods that we've added. And it's creating a new instance of it and then returning it. This is just resetting it with using math.random. We're just getting the bottom of the flake. We will use this later on, and we'll be accessing this in the game module. And this one, nothing new here. We're just using the X and the Y for the image. Draw it. So I think that's going to be it for this one. The next video, I'm going to be doing the collision detection, and then the video after that will be wrapping that up with the sound. So that's going to be all for this one. I hope you enjoyed it. Hope you learned something, and have a nice day.